Welcome back, pre-algebra students. We are starting our third packet, our second full unit, and this unit will be in for a while. It's going to be a longer unit on equations and equation solving. And so I find this unit to be lots of fun. We're going to be doing 1- and 2-step equations, then multi-step equations, and then multi-step equations that have variables on both sides. So you have a variety of examples included in your packet that shows you examples of an addition, subtraction, multiplication, and division problem, and how we're going to solve using inverse operations, so the opposite operations. So if some number plus 14 is 20, and I want to find out what that sum number is, the mystery number, then I would subtract 14, and I'm doing that same thing on both sides of the equation. Now, if you've seen equations before, you may be used to just thinking of, I move the 14 to the other side, and when it crosses the equal sign, it becomes negative 14. Right? So if you have another method, I'd love for you to show me, but I don't want you to just rely on, well, I just knew it was 6, because we're going to get some problems that we aren't going to just know, and we need to have a method that helps us solve. All right? And likewise, for multiplication and division, I want to remind you, will normally be shown as a fraction. And so to get rid of that fraction, I'm multiplying by 2. Multiplying by 2, the 2 on top and a 2 on the bottom becomes a 1. And that's how the k gets by itself in that problem. So it does not make that 2 a 4, because this 2 is on the top, and the 2 that was there originally was on the bottom. Same thing when we're 3n. A multiplication problem, that means 3 times some number, so to undo it, we will divide. So, as I mentioned before, you may think of this in different ways. You may already have a system that works pretty well for you if you've done this before. I always appreciate seeing how different people have learned to do it, but if this is new to you, I would suggest that you always think of the equation like you have to keep it in balance. So the golden rule is whatever you do to one side, you have to do to the other side of the equal sign, the other side of the equation. So if I want to, and I'm trying to get that x by itself, so the x has a 3 being added to it, so notice I need to subtract 3 to make this 3 go away. Whatever I do on the left side of the equal, I need to do on the right side of the equal. Once you get an answer, by the way, for any of these problems, once you get an answer, you can check your answer by plugging it in, substituting it into the equation. So I could do 6 plus 3 equals 9, because this was the x, right? And 6 plus 3, that is 9. So once I know that it's the same, I know it worked. So here, if I do 2 times 4, it should equal 8. Is 2 times 4 8? 2 times 4 is 8. Hooray! Here, if we add 7 to both sides, we get 17. So 17 minus 7, is that 10? Yep, that's 10. All right? So as we do these, especially when we start using more positive and negative numbers, if you're not sure, replace the x with your answer and make sure that it makes sense, that it works. All right? So you have the capability, you have the power to check your answer. So same thing up here. This is just more of the same. I'll go through and do a few of these. These now have some positives and negatives, so we're going to have some integers, so we have to keep in mind those integer rules. So if you're still kind of rusty on those, Be sure you're checking yourself with the calculator, and be sure that you know how to properly use the calculator. Sometimes people aren't typing in what they think they're typing in. And maybe they would be better off just trusting their brain. So I want to get the x by itself, so I want to get rid of the minus 18. So to get rid of that subtract 18, I'll add 18. Whatever I do on the left, I'm going to do on the right. This is gone. And then x is equal to negative 7, positive 18. They're different. I subtract. The bigger one was positive, so it is positive 11. If I check that, does it make sense that 11 take away 18 is equal to negative 7? Yeah, that makes sense. All right, I'm good with that. So you don't have to draw this line down the equal sign. I don't always draw that, but for some of my students, that really helps them focus on when I say both sides of the equation, so that they know they have to be doing it on each side of that line. So again, add a subtraction, so I need to add, very similar to the last one. Probably should have picked a different one. So negative 13 plus 9 is 6. So these top ones are all addition and subtraction. So let's look at one that's addition, number 3. So I would want to get rid of the 5 because it's on the side with the b. So I'm going to do minus 5, I'm going to do minus 5. So then b, and then negative 2, negative 5. They both have negatives, so signs are the same. I can add them together and keep it negative. Again, you can always check. Is 5 plus negative 7 equal to negative 2? And the answer is yes. So hooray, it works. All right, so let's go on. You're going to be finishing up that page on your own, all right? And then these are some multiplication and division problems. Notice the multiplication, the ones on the left, that's when the number is written right next to the variable, all right? So sometimes people misinterpret and think that this, number 3, think that we need to add 11. But this is not the same as if I wrote that. This would be x subtract 11, and I would add 11. This means negative 11. This means negative 11 times x. So to get rid of this negative 11, I need to divide by negative 11. And when I'm dividing, I want to divide by that exact number. We also call, remember that, the coefficient. So I want to divide by that exact number, because if I divide by positive 11, I'm really left with negative x. And I don't want x to be negative, I want it to be positive. So I divide both sides by negative 11. Now I have x is equal to 209 divided by 11 is 19. The signs are the same, so it is positive 19. And then an example over on the right-hand side, these are division. So fractions indicate division. So to undo division, we're going to multiply. So I'm going to multiply this side by 9 and this side by 9. Notice I put the 9 like up in the air, not down in the bottom. So then this 9 and this 9, because they're really like this, they're on top of each other, 9 divided by 9 is just 1. And we don't need to write 1x, we can simply write x, and then 6 times 9 is 54. You can check these also. 54, divided by 9, yes, that is 6. So that kind of helps me know for sure that it worked. So if there's a fraction, you're going to multiply by what's in the denominator of that fraction. So then this would be b is negative 78. Okay, very good. So you have some additional problems on this page to finish. And that gives you some examples of one-step equations, and then I will make a separate video and have it posted for two-step equations. So again, one-step equations, page 3 and 4, you have some problems to finish for one-step equations.